deposit an egg down there, wait for the egg, the bee larva to hatch and start eating the pollen ball that its mom has left for it. And once that pollen ball is completely eaten and the larvae is really big and ready to pupate, then these little babies will come into action. They're like a vampire that all of a sudden appears from the side of the wall, and it sinks its teeth in, and they completely, basically suck the husk dry in order to turn into the next life cycle. Kind of a really interesting, from my perspective as a scientist, thing about the velvet ants is that there's a lot of diversity of them. Every one of these up here represents a different species. So you might see a whole bunch that look really similar to one another, but they're all different species from one another. And what we see, again, is this convergence towards a similar pattern of some kind. And what these numbers represent is that if you made a family tree of these things, okay, to see how they were all related to one another, the numbers relate how closely related to one another they are. So I'm just going to point out a few examples to you. Here's a number 41 right next to the number 1. Those are really distantly related from one another on the family tree, but they look pretty close to one another. And we can find more and more examples of that down here, where the really distantly related things actually look an awful lot like one another. And so we call this convergent evolution. Why? Because they're all, as these letters or colors show you, occurring in the same area. And it's a mimicry ring, okay? They're all kind of mimicking one another, again, to strengthen that signal to potential predators. That strength, if I seem like, just the worst thing ever, and so do I, 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 and we all live in the same neighborhood, then predators have to remember 1, 2, 3, 4, 5, 6 different search patterns in order to go, I should avoid that, okay? But if I'm a predator who lives here, I can pretty much get away with kind of recognizing these all orange hairy things are bad, okay? So there's this natural selection towards this convergence. So most of our species, are kind of in this category or in this category around here. But we got a lot of species here in San Diego. Honeybees! Honeybees are everywhere. They're everywhere, they're everywhere, they're everywhere. These are the European honeybees. And what are they doing right here? They're drinking a little bit of water, which is something that we see pretty often here in San Diego, particularly late in the summer. The drier it gets outside, all of a sudden they're coming to that drippy faucet that you've got outside or somewhere, or along the edges of puddles that are slowly evaporating down. So are they drinking that water because they're dehydrated? Nah, they get a lot of their liquid from drinking nectar from plants. So really what they're doing is drinking that water up to take it back to the hive. Because imagine a hive inside of a cavity. It's inside of a box or inside of a tree cavity of some kind. And inside that cavity are all these bee larvae. And they're metabolizing all of that honey, okay? So they're cranking out metabolic heat. And so in addition to it being hot outside, they're generating heat inside. And so we have to worry about this critical thermal maximum again, basically baking ourselves to death. How do they avoid baking themselves to death? Swamp cooler, okay? They go back to the hive and can sit at the hive entrance, blow out this water out onto their face, kind of cover their face up in water, and start to flap their wings to get evaporative cooling off of their body in order to cool the hive down.
So they're misters.
They're misters, exactly. You got it. I love it. And most often when we're out on the trail and we see bees, they're mostly European honeybees, common honeybees. But in terms of species diversity, our native bees are the lion's share of what we've got here. There are over 500 species of native bees in San Diego County. And this is really just to kind of show you a few of them. These are these cute little guys called Perdita. And there's a whole bunch of different species of these. Really, really small bees that kind of look wasp-like. They don't look really hairy to you. But they are indeed little bees, and they specialize. This particular species just specializes on this family of plants. And then here's some other ones. These are male bees, actually, that had to sleep overnight, and so they grasped onto this little stem here. That's why they're covered in dew. Looks like a yellow jacket, right? It kind of looks like a yellow jacket of some kind, but this is actually what we call a leafcutter bee, and it's carrying pollen on the underside of its abdomen instead of on its arms, and that's one way that you can identify them. And the diversity is huge in terms of size. This is the smallest bee in North America. It's Perdita minima, and this is the head of the biggest bee in North America, which is Bombus sonoris. And one that I'm sure you guys see around here are carpenter bees, and you might see the black ones like this going around foraging from flower to flower. They're big. They're our biggest ones that we have around here. But you also might see the golden one, okay? And the golden one is a male. It's called the valley carpenter bee. Not all carpenter bees do this, but the valley carpenter bee, the male is golden and the female is black. And the males will hover around areas where there's lots of dead wood of some kind, because they're called carpenter bees for a reason, okay? And what the males are doing is being territorial. They're marking their area, saying like, I've got good real estate right here, and waiting for females to come along, and then they mate with the females, and then the females nest within the area that they're protecting, and they'll move on to another site. And they are incredibly territorial and aggressive. And if you take small pebbles that are the right size and throw them up in the air around them, they will chase them down, because they'll chase anything that approximates the size that they're after. I said we were going to talk some more about galls. Oaks have tons of galls on them, tons and tons and tons of different types of galls on oaks. This is called an oak apple gall. This is clearly an oak leaf right here, but it looks like it's got apples growing on it. And again, this is a little wasp. There are a group of wasps that do this, that basically insert an egg into a growing meristem of the plant, and we develop this kind of plant cancer, this gall in which the side the larvae feed. And one that I took a picture of just last Friday was this really weird one called the spiny turban gall, okay, that is on more of like a chaparral oak. And you can see they're just on the leaves, but this plant was covered with them. I mean, absolutely covered with them. And so I'm going to give you a reference at the very end of this if you're interested in galls, that should be your go-to reference, but tons of interesting cool galls out there. Briefly talk about harvester ants. This is just an interesting thing that I pulled out of the literature. Harvester ants are used by some, or have been historically used by some indigenous groups in Central California, where they would actually eat, what's the number? Often exceeding 400 of them unmasticated, which means I guess they're swallowing them whole, they're not chewing them up. And that it would induce a kind of a dream state in which they would like see their, dream diet or something like that. But the reason, to me, this is particularly unsettling is if you've ever been stung by a harvester ant, then they really pack a punch, and it's a punch that lasts for a long time. And so to have all those down in your gut is profoundly disturbing to me. But we do see harvester ants around here. They're one of our larger, a lot of people call them red ants around here. They're one of our larger ants that we see out on the trail. They often keep an area cleared out around their trail. They're pretty good about doing that. And the reason why they're called harvester ants is because they do go around and they harvest seeds, not to eat the seeds, but there's a whole lot of plants in Southern California that have these little fruiting bodies on them that are called eliosomes, and they're basically like little power bars, okay? And these seeds have actually adapted to kind of work side by side with the harvester ants. We're going to let you eat this little power bar that's associated to our seed in order for the service of you moving the seeds away from just right underneath the mother plant, okay? So seed dispersal. So there's the hero of our story. Love harvester ants. They're such a cool native ant. And then here's the villain of our story. This is the evil Argentine ant, okay? Boo. Okay? And the Argentine ant is an invasive species. It's not native to Southern California. It's native to Argentina, as the name suggests. And why are we booing and hissing them? Well, invasive species in general are just a bad thing. We should boo and hiss most of them. But the particularly bad story here is that they don't get along with other ants, okay? So there have been studies done within Southern California of areas pre-Argentine ants and post-Argentine ants, and areas like San Elijo Lagoon, for instance, which is just right downstream from here pretty much, had 30 plus species of ants when they were surveyed pre-Argentine ants invasion. You go out there now and you're lucky to find 4 or 5 species of ants. So the diversity of ants really decreases, but they particularly seem to have it out for big ants, like the harvester ants. This is a big ant, 1 millimeter, 1 millimeter. These are small ants. And the problem with that is that there's a lizard around here called the coast horned lizard. And it's one of the most common questions that I get when I talk to people who've lived in San Diego all their life. What's happened to all the horned lizards? I used to see way more horned lizards when I was younger, you know. And one of the reasons, besides the fact that they compete with us for coastal habitat, right? Besides habitat destruction, is that even in the areas that aren't destroyed, the ant diversity has gone down because of the invasion of Argentine ants. And these coast horned lizards, their preferred food are ants. We would go, well, so what? You just replaced one ant with another ant. Like there's plenty of Argentine ants out there, no shortage of Argentine ants. But they don't perceive ants below a certain size class to be food. So even though it's like water all around, not a drop to drink, even though there's ants all around, they don't perceive them as food, and so they will actually starve surrounded by ants. And there's been some decent work done by scientists at UCSD on this very issue. One of the great stories of symbiosis and collaboration within the natural world is that of the yucca moth and the yucca plant. And here we see a beautiful yucca blooming in the middle of some area of San Diego. And inside of the little flowers, if you opened up those little flowers, or even if you go up to one, sometimes go up to a flowering stalk and just shake it. And you'll see, it's like a cloud of little moths will come out of it, and then they'll settle back down inside of it. And those little moths are these yucca moths. And unlike bees who pollinate plants, but they just do it because they're out there to get nectar and pollen, right? That's what they're after, and they serendipitously pollinate the plants. These purposefully pollinate the plant. What they do is they have got specialized mouth parts that they grab the pollen with, and they take that pollen from one flower, from the male parts, they take it to the female parts, and they plant it down on there. I'm pollinating you, okay? And why do they do that? Why do they do this service? Because then after they do that, they go down to the base of that flower where the seeds are going to be developing, and they deposit eggs into the developing egg chamber. Now, you might go, well, how's that going to ever continue? Because aren't all their larvae going to eat all the seeds that are inside? And eventually, over evolutionary time, that's going to, not pan out. But that's not what happens. They actually, know, or they've been, they've evolved, to only inject eggs into a certain number of the capsules. If you've seen the fruit of a yucca, you know that it's divided up into capsules. So they'll only insert larvae into maybe 2 or 3 of the capsules and leave the other one. So it's kind of like, I'm going to pollinate you. In return, I'm going to eat some of your seeds, but you get a lot of seeds out of it as well. Neat story. Looks like a bee, but it's not a bee, it's a fly. It has one set of wings. Bees have 2 sets of wings, but you'll often see these when you're out on the trail hovering around. They're the ones that kind of hover in place for extended periods of time. Oftentimes they've got kind of a silver band on them somewhere that kind of stands out a little bit. Lots of different species of these bee flies. And you might have wondered, well, what do they do with their life? What are they doing besides hovering around there? Well, they feed on nectar, okay? But what's the interesting part is that what their larvae do. And so you can see there's a little hole right here in the ground. There's a little hole right here in the ground. And these are the nesting entrances for a specific native bee, okay? And what happens, when I was taking this picture right here, this bee was hovering over the bee fly, was hovering over this hole, and its abdomen kept going like this. The end of the abdomen kept going like that. And you can observe this if you can have the luck of finding this. And what was its abdomen doing? It was dive bombing eggs down in there. It was shooting eggs down into this little hole. And when the eggs hatch, they're precocious. They hatch immediately and they just scramble down into the gallery of this bee until they find a chamber where there's a developing bee larva. and then they feed on it, like kind of like the velvet ants that we were talking about earlier. So falls into this group that we call parasitoids, and there's tons of different insects.
How did it develop the behavior to shoot the eggs in rather than just like, casually, like?
Yeah,
That's bizarre.
I'm gonna do some armchair, like evolutionary biology here, and tell you where I think that might manifest itself or how it could. Is that like the velvet ants, for instance, they actually are going down into the galleries. And we could go back, you can look, at pictures online. They are armored thick. Like their bodies, like you could step on one and potentially not crush one. They are so thick with armor. And that's because while they're crawling around down in there, they encounter a mom bee, she's gonna be mad, right? And she's gonna be trying to sting them like crazy, and they're gonna be trying to get out. These are not nearly as armored, and I suspect, certainly, they don't want to crawl down in there because of that, possibility. But also, even why not just sit on the ground and kind of plop them over the edge? I think it's possibly this idea of being able to take flight quickly. But I'm hypothesizing. Okay, I think this might be our last slide. There's one more after this, but this is just to introduce you to the next slide, which is the gall midges. Again, I said I was going to talk to you about galls. So far we've seen aphid galls caused by aphids. We've seen galls caused by wasps. But this is one of the larger groups of gall-making insects, and those are the gall midges. And there's over 1,100 species in North America. The adults, you'll probably never see, okay? They're basically gnats. They're little tiny flies. But you'll see evidence of their larvae on lots of different types of plants. And so here we've got one called, Rhopalmia flacosa. Boy. But this is on coastal sagebush right here. So if you've seen coastal sagebush that looks like somebody's put cotton all along the stem of it, that's caused by this gall midge. Okay? So inside of that, if you had a microscope and you delicately dissected this, remembering that the larvae is going to be incredibly small, you would find a little larvae down inside of there. This is on black sage, and so this is called the black sage tubular gall. Okay, and so we can see this, and it's a completely different species. So a lot of host plant specificity within these gall-making insects. And I was trying to, as I was crafting this and putting this together, trying to think about, what sort of host plants, should I choose that would be appropriate for here? And I think these are appropriate for here. But then, as I came in and was walking over the restrooms, willows have tons of galls on them. And so there's definitely good gall stories for you to tell on the willows as well. Which brings us to our resources section of the talk. So, I'll go to the very last slide. The end? Question mark? No, it's never the end when it comes to insects, okay? Because there's so many of them. There's countless stories to tell. And so you need more resources so you can find out about what those are. And these are my recommendations to you. I own no stock in any of these books or companies, okay? But this is the one that I kept referring to over and over again. It's a field guide to plant galls of California and other western states. Great resource because it's so specific to us. And it's organized in such a way that if you know your host plant, you can find your gall pretty easily. And tons of pictures, so tons of pictures. Okay. Tracks and signs of insects and other invertebrates, Guide to North American Species. So this is a much bigger book, okay? And it's going to include a lot of things that are East Coast things and Central, all that sort of stuff. But it's cool because it's tracks and signs. So if you're into scat and paw prints and stuff like that, you can turn into a certified insect tracker sometime, okay? This is kind of like what I consider to be the Bible of field guides of Southern California, even though it says desert insects and their kin. It's such a great resource. It's super fat. It's like this big. Tons of colored pictures that are in it. And lots of good, even though it focuses on the desert, there's still lots of good information in there that will help at least get you in the right direction. If you find something you're curious what it is, if you can find something close to it in there, then you're on the right track. And then you can go to this website called bugguide.net, knowing what you know from that book, and maybe see if you can find out specifically what you found. And so this is a website that it's not as easy as I think it could be, but you can submit photographs to it with requests for identification. So if you're interested in that, that website's your thing. And then butterflies is our favorite flowering plants. Again, this is desert, Borrego Desert State Park, but there's a lot of butterflies that occur in both areas, and the reason why I like it is because they actually focus a lot on their favorite flowering plants. So again, you can tell those plant stories and butterfly stories side by side. And then the last one, which is like the Bible of butterflies of San Diego, is the Butterflies of San Diego County. And this is a print-on-demand book. So you have to like you Google it and you'll go to a website and it's a little bit costly, but they'll print it for you on demand. So that's it. Again, my name is Michael Wall. I work at the San Diego Natural History Museum. My email address is mwall@sdnhm.org. And if you find cool stuff that you want to share with me or you've got other questions, feel free to contact me at any time. I'm happy to take any questions now as well.
I have one question.
Yep.
So on my car once, I had what I figured out were seeds, but they look like, or not seeds, eggs. They look like a strip of paper. I don't know if you've ever seen that candy. It's like a strip of paper with like little dots of hard candy.
Huh.
And I had no idea what it was. And I scraped it, and it turned out it was some sort of.
It was eggs of some kind.
Yeah, exactly.
There are some aquatic insects that make something kind of like what you're describing. All Helgamites or the Dobson flies, but it would be unusual to find them on a car. These are what I'm thinking of. You typically find underneath overpasses. You'll see these things that you might think are spider kind of little egg sacs packed onto the side of the wall, but it's actually these Dobson flies. So I'm not sure, but if you see it again and send me a picture, I'll do my best.
How many of the mantids are native?
It's a good question. And we've got, this is totally an estimate, but I have looked into this in the past and I just can't remember the exact number. I would say we've got about half a dozen native species. But then there's a number of non-native or native or East Coast transplants. So we've got non-native like from the Chinese mantid, but then we also have some East Coast transplants as well. Yep.
Are there any medicines that are derived from insects?
I cut that slide out. It's actually part of So there is blister beetles, which you see more commonly over in the desert, but we certainly have them around here. Blister beetles are, the reason why they're called blister beetles is because they do this thing called reflexive bleeding, which would basically be like if I went and I could squeeze blood out of my joints, they can do that. So they can force their hemolymph out of their joints, and their hemolymph contains this toxic compound that causes blisters and burn wounds. So you might go, well, how's that medicine, Michael?